In this task we have a projector lamp and it needs a nominal voltage of 75 volts. But we want to connect it to our electricity network with 230 volts. Okay, it would burn through if we connect it directly, and therefore we build a voltage divider. And of course we could use a resistor, but a resistor consumes active power and we have to pay for that. And therefore we just connect an inductor in series, because an inductor consumes reactive power and that is for free. Okay, the lamp has nominal voltage of 75 volts and there a power consumption of 250 watts. Let's model it to be a resistor and therefore let's calculate its resistance in the first place. So we know the power can be calculated by voltage squared divided by R, and therefore the resistance of our lamp can be calculated like this with the values given, and that leads us to a resistance of 22.5 ohms. And now we should find the value for the inductor. Good, we know we want to have a voltage drop at the resistor, at the lamp, of 75 volts, and therefore we have to find the voltage drop here. And it's not just UN minus U, because we have sinusoidal voltages and a sinusoidal current here. And let's have a look at the phasor diagram. So the current is the same in both elements. And at our lamp, it's in phase. But at the inductor, the voltage leads by 90 degrees and therefore the total voltage looks like this. Kirchhoff's voltage law is that U plus the complex UL minus the complex UN equals 0, not just the absolute values of them. Okay, we see we have a rectangle with a 90 degrees angle, and therefore we can use Pythagoras, and it looks like this. I want to find the voltage drop at the inductor, and therefore we solve it for the voltage and put in the number values, and we find out that the voltage drop at our inductor is 217.43 volts. We can calculate the current that flows there. We know the voltage drop at the lamp and we know its resistance, and therefore we find the value of our current. And now we can use Ohm's law at the inductor, and it looks like this. We have no complex J there because we are dealing now with the absolute values. So the complex equation would be UL complex equals J omega L times complex I. Okay, and we can solve this equation here for L, and therefore we get this here. Okay, and now we should calculate the apparent power and the reactive power of our circuit. Okay, we have the current, we have the total voltage from our net, and therefore the apparent power is just the absolute value of our net voltage times the absolute value of our current. And therefore it's this here. Okay, the apparent power is the complex sum of the active power and the reactive power. And if we deal with absolute values, we have to use Pythagoras again. So, and now we want to have the reactive power, so we solve for it. And yeah, we have the apparent power, just calculated. We have the active power, it's the power consumption of the lamp. And therefore we have everything to find the reactive power. And in the end we are asked for the power factor lambda, and this power factor is just defined by the active power divided by the apparent power. The active power was given, we calculated the apparent power, and therefore it's this.